One type of problem that you'll find is very familiar in the AP Calculus world is problems that involve accumulation, or things that are going in or out or coming and going. So at the end of this lesson, you'll be able to solve accumulations and in-out problems. Right. The integral is a natural, I'm just going to read this. The integral is a natural tool to calculate net change in total accumulation of more quantities than just distance and velocity. Integrals can also be used to calculate growth, decay, and consumption. Whenever you want to find the cumulative effect of a varying rate of change, you integrate it. And we actually have done several problems like this already. We've dealt with Fluffy the cat. We had some eggshells from our exam problems. So we've had quite a few of these problems already. So this is almost just a little bit of a recap of how you do them. So this first example says, from 1970 to 1980, the rate of potato consumption in a particular country was C of t is equal to 2.2 plus 1.1 to the t millions of bushels per year, with t being years since the beginning of 1970. How many bushels were consumed from the beginning of 1972 to the end of 1973? Okay, a few things that I like to do when I get started. I see units, so even if I'm not sure how to start a problem, I look at the units. C of t is measured in millions of bushels per year. Keyword there is per. Then it asks for me how many bushels. So I'm starting with millions of bushels per year, and they want to know how many bushels. So the rate is dropping out. Whenever the rate is dropping out, we want to take the integral to have that happen. So we're going to be taking the integral of C of t. Okay, what we need to figure out, though, is from where to where. So 1970, I think I forgot to put this, t being years since the beginning of 1970. So the beginning of 1970 is going to be t equals 0. So the beginning of 1971 will be t equals 1. The beginning of 1972 will be t equals 2. The beginning of 1973 will be t equals 3. The beginning of 1974 will be t equals 4. So it says how many bushels were consumed from the beginning of 1972, so the beginning of 1972 is t equals 2, until the end of 1973. So if 1973 has ended, that would mean it would be the beginning of 1974, which would be t equals 4. So now from here, excuse me, we can just go ahead and put this C of t formula in. Still respect to t. And then from here, we will use Math 9, and we'll be able to use Math 9 on all of our problems this time. And when we do that, we should get 7.066. And it said how many bushels, but I do notice that they're measuring them in millions, so it's going to be 7.066 million bushels. And it's not per year anymore, it's just bushels. Okay. Accumulation. Many problems involve simultaneous flows in and out. To find the net change, we need to consider both how much is added and how much is removed. So we're going to, sometimes it's going to be something being pumped into a tank and then other things being pumped out of a tank. It might be things growing and decaying. It might be things being born and then dying. It might be things entering an intersection and then leaving the intersection. We'll see people going into the park, people going out of the park. So those would be all different examples of things going in and out or coming and going. So let's take a look at this example. From noon until 6 p.m., the rate at which people enter an amusement park at time t is given by E of t, for which the graph is shown below, where t equals 0 corresponds to noon and t equals 6 is 6 p.m. People are also leaving at the rate of L of t equals 50 times the quantity 2 plus t squared e to the negative t over 5. If 3,000 people are in the park at noon, how many people are in the park at 6, rounded to the nearest multiple of 100? So it's asking for how many people, and I notice for both of these, the E of t and the L of t, those are rates, so they would be people per hour, which means we're going to take the integral to figure out how many people. So I'm just going to break this up into a 3-part problem and then show you how we could put it all together. So first of all, let's figure out how many people are entering the park in that time frame. Okay, so entering the park, that would be the integral from 0 to 6, and it would be E of t. Okay, because E of t is people per hour. If I take the integral of that, I'll just be left with people. Okay, it did tell us that this is the graph of E of t, and if I want to find the integral of a graph, I know, excuse me, I'm going to find the area under the curve, so I'm going to find this whole area under the curve, and there's probably more than one way you could do it. I'm going to go ahead and break it up into 3 sections, and you could pick different ways, and that's okay. Right, I'm going to break it up into A, B, and C. I have 2 trapezoids and a rectangle. You could definitely break it up into many different ways, and that's fine. Okay, so A is going to be a trapezoid. It's 1/2 times the height. The height of that trapezoid, because it's a trapezoid on its side, is going to be 3. One of the bases is 400, and one of the bases is 600. Okay, and if we multiply that out, we will get 1,500. Okay, area B is a rectangle. It's just going to be length times width, so 1 times 600, which will give me 600. And then C is another, excuse me, another trapezoid, so it's going to be 1/2 times the height, and again, it's a trapezoid on its side, so it's going to be 1/2 times 2, and then the sum of the bases, the larger base is 600, the smaller base is 500, and if I multiply that out, I will get 1,100. So if I add those all up, 1,500 plus 600 plus 1,100, the people entering the park, there were 3,200 of them. Okay, now let's look at the people leaving the park. Okay, so if I want to know how many people left, I will take the integral from 0 to 6 of L of t, dt. Okay, for this one we just have a formula, so we'll be able to use math 9 for. So if you just do math 9 on that function, you will end up getting 2,106 people. So we have 3,200 people entering, we have 2,106 people leaving, and it says how many people are in the park at 6. Well, we need to consider that there were already 3,000 people there to start with. So we had 3,000 people there to start with. We added 3,200 with the people entering. We subtract 2,106 from the people leaving. That leaves 4,094 people in the park at 6 p.m. It does say to round to the nearest multiple of 100, so if I round that to the hundreds, it's going to be 4,100 people. Another way that I could write this, just to make it look a little bit more mathy, I guess, we could have 3,000 plus the integral of the people entering minus 0 to 6, the people leaving. So that would be a good, sometimes on a problem it might just ask for the integral setup, and that would be the integral setup. Okay, let's try another one. You might want to try this one on your own and come back and see how you do. A penguin population is such that the rate at which penguins are born in a given year is modeled by the function b, defined by b of t equals 1,000 e to the 0.01 t. The rate at which penguins die in the same year is modeled by the function d, defined by d of t equals 250 e to the 0.06 t. Both b of t and d of t are measured in penguins per year, and t is measured in years. These functions are valid for any years between 0 and 40. At time t equals 0, there are 100,000 penguins. What is the penguin population after 25 years? So again, we have rates. Both of those are measured in penguins per year. So if I just want to know how many penguins, I will be taking the integral. My integral setup, I'm just going to put p for penguins. I'll write penguins. My penguin population is going to equal how many I started with. Okay, and then I'm going to add how many were born. So to get how many were born, we're going to go from 0 to 25 of b of t, and then I'm going to subtract how many died, which would be the integral of d of t. All right, so that would be my integral setup, and again, a lot of times the problem will just ask for the integral setup, and that's that. Now from here, I'm just going to go ahead and calculate. I have 100,000. If I use my math 9 button for this one, I will get 28402.542, and then minus, if I do my math 9 for that one, I get 14507.038, and if I add and subtract that, I get 113,895.504 penguins. It didn't say what to round to, so I'm going to keep it at 3 places. Generally, it will say to the nearest penguin, and if it did, it would be 113,896 penguins. And then that would be my answer. So hopefully now you are familiar with accumulation and in and out problems.